This video is for those of you who missed our discussion of differential equations. If you were not there that half a day during the AP Blitz, and we spent most of the day talking about how to solve differential equations. The first thing we want to understand is what is a differential equation. So, of course, it has to be an equation. There you see one. And the differential means that there's a derivative involved. And you can see that there is a y prime. So that's the right combination. You have a derivative, you have an equation. You could call it a derivative equation, but we just say it's a differential equation. Now here on the side they said that y is equal to 1 when x is equal to 0. We have a name for that. We call it an initial condition. If you are in a science class, they call it a boundary condition. But for math terms, we just say it's an initial condition. And so then what does it mean to solve the differential equation? Sometimes they're going to say solve it. Sometimes, like this example here, it says to find the particular solution. To solve it means find the y function so that when you take its derivative and you multiply by 3, it gives you this expression. So you're supposed to find a y function whose derivative multiplied by 3 gives you x over y. And the way we go about it is to go down a list of steps. The first step is see that y prime. We need to change that. And I'm going to write it this way. 3 dy dx is equal to x over y. Sometimes they give you the derivative in terms of dy dx, but if it's not written that way, then you change it to dy dx. And then the next rule says you want to separate the variables. And that means that you want to have all the y's with the dy term, and you want to have all the x's with the dx term. And so to do that, though, we need to separate dy and dx. And so I'm going to multiply by dx because that is the denominator, and it's an equation, so I do it to both sides. And so then we have 3 dy equals x over y dx. So the first thing you want to do is remove dx from dy. Now you separate the variables. All the y's go to the dy side and all the x's go to the dx side. I can see that my x is already in the right location because there's dx next to it, but the y needs to be moved over to the left side. And to do that, we'll multiply by y because it's dividing. And so then we have 3y dy equals x dx. And you do want to keep the dy as the last term on that line, and you want to have dx as the last item on that side. So here we've separated the variables. Y's with dy, x's with dx. And when you look at it, it's almost as if it's missing something, this expression here. You could almost feel it that there's something missing. And isn't it true that most of the times when we have a dy or a dx, it's because we're integrating something, but we don't see any integral signs. And because this is an equation, then you can do whatever you want to do to this equation. You could add 7 to both sides if you wanted to. You could divide by 17.3 if you wanted to. You could raise both sides to the 5th power. You could take the ln of both sides. You can do anything you want as long as you do it to both sides. And so because we see dy and dx, then naturally we think of let's integrate both sides. So we integrate the left-hand side, but because this is an equation, then we also integrate the right-hand side. Okay? And we are on our way to solving the differential equation. So now, just integrate. The integral of 3y would be, with respect to y, it'd be 3y squared divided by 2. And Just for now, I'm going to say that it's plus its own c value. And then I integrate the other side, and that would be x squared over 2. And this also has its own c value. And I guess to differentiate them, I should call this one maybe c sub 1, and I should call this c sub 2. But this is the only time this is the only example where I'm going to do this, and then later on I'm just going to ignore the c1 on this side. As soon as you integrate, you notice that, hey, look, there's the y, and to find the particular solution means to find the y function. So this is your y. All you have to do now is solve for y, and you're done. To solve for y, then I start moving terms around, and one of the terms I want to move right away is this plus c1. So I subtracted, oops, not c2 but c1. And then when we do that, we have 3y squared over 2 equals x squared over 2. And when you think about it, these are two constants. And when we add two constants together, we just get another constant. So it's just like having another c value there. The addition of two constants is just one constant. So we're going to save some time, and later on, instead of saying there's a plus c on this side and there's a plus c on that side, and then we combine them and we end up with a plus c, all I'm going to do is I'm going to integrate the left without a plus c. I'm going to integrate the right side, and then I will show the constant of integration just at the end on the right hand side because I'm solving for y. And this will always happen. You always end up with two constants, but they combine into some other constant, and we'll just call that one c. And so we don't really need to observe this one here all the time. Now here we are, 3 over 2 y squared equals x squared over 2 plus c, and we want to solve for y. But before we solve for y, we notice that now we have to take care of this c value, and we have to figure out what is that c. My advice to you is, as soon as you see that the constant shows up, that's a good time to find the value of c. Many people solve for y for the y, and then after they solve for y, they try to find the c value. I think it'll save you some time and a bit of a headache if you just say, hey, there's a c value, I'm going to find it now. How do we find the c value? They gave you an initial condition. So we just do a plain old substitution. We let x be 0, we let y be 1, and we find the c value. So then we have 3 halves, the y value is 1 squared, equals the x value is 0 squared divided by 2 plus your c value. So then that yields 3 halves equals 0 plus c, or c equals 3 halves. So now we can come back to the equation where we stopped. We stopped right there to find the c value. So we come back to that same location and say, now we know what c equals. So the equation we have now is 3 halves y squared equals x squared over 2. And instead of plus c, now we have plus 3 halves. And now we would like to solve for y. And one thing I notice is that, hey, I can multiply everything by 2 to cancel out the denominator. So we just have 3y squared equals x squared plus 3. I don't have to show you that multiplication, right? You guys can see what's going to happen. And then I divide by 3. I can divide individually by 3, or I can just divide the whole thing by 3. This is up to you. I guess I'll go individually. So we have y squared equals x squared over 3 plus 1. But I'm not interested in y squared. I just want to know what the y equals. So then I have to take the square root of this. Square root here, square root there. And when you do that, you're going to end up with a plus or minus. Y equals plus or minus the square root of x squared over 3 plus 1. Okay? And it looks like we're almost there. We solved for y, except we need to take care of this plus or minus dilemma. Is it a positive or a negative? Right now you actually have two solutions, but when you look back to the question, it says find the particular solution. That makes it sound like a unique solution. So out of these two, we need to select, is it the positive square root or the negative square root? How do we know which way to go about it? Well, again, think about the initial condition. When you let x be 0, the y is supposed to be 1, and it's supposed to be positive 1. So then let's do some mental math. If I let x be 0, I'll get 0 divided by 3, 0, plus 1, 1, and then square root of 1. Well, the square root of 1 is going to be either plus or minus 1. But so that the y equals whatever the initial condition said, we would have to select the positive square root. So we are ready to write down y equals the positive square root, I don't need to show the plus sign, of x squared over 3 plus 1. If you keep in mind the initial conditions at all times, then you should be able to figure out things like this plus or minus. Always be on the lookout for a plus or minus if there's a square root involved, and make sure you consider the initial condition. So this is the answer. And what are we saying? We're saying that if this is y and you take its derivative and you multiply by 3, you should get x divided by y. And I'll show you how that works in a little while. But now let me tell you how we actually earn points on if this is a free response question. So the very first thing is this first thing we did, which was just move the dy and the dx's and let the x go with dx and let the y go to the dy term. This actually gives you 1 point. If this is a free response question, just for separating the variables. That's what that's called, separating the variables. And then the second point comes from integrating. If you actually integrate the right way, and this is the right integral for this, and this is the right integral for that, right at this point, after you finish the integration, they'll give you another point for the integrand. So that's 2 points. And then, if you use the initial conditions, using the initial conditions here, and finding the c value, that gives you another point. And now, solving for y, and making sure you decide on the plus or minus, that gets you another point. And we're missing at least one other point, and I can tell you that that's either going to come from, sometimes they say consider the initial conditions as 1 point. So I'm thinking if you use the right initial conditions, or if you use the initial conditions to figure out that it had to be the positive square root, just the fact that you use the initial conditions yields another point. So that's a total of 1, 2, 3, 4, 5 points. And if the problem is a little more involved, like the one I'll work on later, you can actually get 6 points out of this. But definitely 1 point for separating the variables, 1 point for integrating, 1 point for using the initial condition, 1 point for solving for c, 1 point for solving for y, and making sure that you have the right expression for it. This is 5 points. A free response question is worth about 9 points. So 5 out of 9 points is pretty good. And this might just be part A of the question, which would be to solve to find the particular solution. So now I rewrote my particular solution here, and I want to show you now why this is the solution to the differential equation. The differential equation says take 3 times y prime. So I'll do that just now. I'm going to take the derivative of this function here. Before I take the derivative, maybe I should rewrite it. This is x squared over 3 plus 1 quantity raised to the 1/2 power. So then y prime equals, this will be the power rule. Let me try that again. Y prime equals power rule. Bring down the power, 1/2, keep the base, x squared over 3 plus 1, raised to the, take away 1 from the power, negative 1/2, then times the derivative of the base, that would be 2/3 x. So that's y prime. Now the problem says 3 times y prime, so if I multiply this by 3, we'll get 3y prime equals, and then you can see that if I multiply here by 3, it'll cancel this 3 here, so then I'll end up with 2x here, and then this 2 is going to cancel with this 1/2, so basically what I have is just x times this amount. So let me write that down. X times x squared over 3 plus 1 to the negative 1/2. And if I rewrite it, it'll be 3y prime equals, let me rewrite it so that there's no negative exponent, and that would be x over, and then I send this thing with the negative 1/2 to the denominator, and it'll be to the positive 1/2, which means the square root of it, the square root of x squared over 3 plus 1. And this is 3 times y prime. Now based on the original equation, 3 times y prime should equal x over y. Now this doesn't really look like x over y, it looks like x over something. But hey, then take a look. Isn't the denominator exactly the same as y? It is. So in essence, 3y prime does equal x over y. And this is just me doing a check, a double check, to make sure that you see how separating the variables, integrating both sides, using the initial condition, those are the steps you need to take to solve the equation. So do you have to check your solutions on a free response part of the AP exam? The answer is no. This is not required of you. You don't have to do any check. Actually, you don't have time to double check anything. You just do the first part of the problem, you come up with your function, and as soon as you get your function, you kind of have to trust that you have the right thing and that you did the right math. And it would be nice if you could check, but there's no time for it. So, but I did want to show you that our solution was the right solution to the differential equation. Okay. Here's a second example. Find the particular solution to ds dt equals 5s minus 3, given that s of 0 is equal to 4. And so then the question doesn't always have x and y. This one has s and t. S depends on t. So think of s as your y and t as your x values. Same steps as before. We have to separate the variables. Before we separate the variables, we want to separate dt from ds. And so we'll multiply both sides by dt. And we get ds equals 5s minus 3 times dt. Now at this point, this poses a problem for some students because the next thing would be to move things around so that the s goes to ds, the s's go to ds, and everything else goes to dt. And so some people might be tempted to do this. Take away 5s, take away 5s, and then they'll end up with something like negative 5s ds equals negative 3 dt, and then they want to integrate both sides. But at this point, they've already made a mistake, and everything else you do after this will not be correct, and you will not earn any points whatsoever. And where's the mistake? The mistake is in not realizing that when you multiply both sides by dt, you're actually saying everything here is multiplied by dt. So 5s minus 3 needs to be in parentheses. Okay? Now that's more like it. So now you can see that when you move the s terms over to the ds, you're actually moving the entire 5s minus 3. So it'll be a division because 5s minus 3 is multiplying. And so we have, I think it's best if I write it this way, 1 over 5s minus 3 ds equals dt. And at this point, you can integrate both sides. So now integrating this, we probably need a substitution on the left-hand side. We can say let u be 5s minus 3. So then du is equal to 5 ds. Or, because we don't see a 5 ds in the original integral expression, then we can say that 1/5 du is equal to ds. And so our integral becomes the integral of 1 over u, and ds becomes 1/5, which is a constant, so we can factor out du. And that equals the integral of dt. And let me bring this way up here and go from there. So now we have 1/5 times the integral of 1 over u. That's simple enough. It's the ln of the absolute value of u. Now remember, this integral has a plus c, but I'm not going to write it in. I'm just going to keep it in mind. Equals, now I integrate dt. I'm actually integrating 1 dt, and the integral of 1 dt is t. Now this right-hand side also has a plus c of its own, and when I combine the plus c from the left-hand side to the plus c from the right-hand side, then we just end up with 1 c value, plus 1 c value. Okay? And let me do a back substitution now. So 1/5 ln of the absolute value of u, which is 5s minus 3, is equal to t plus c. Okay? Now, I told you in the last example that the best time to find the c value was whenever it first appeared, but on this one I'm actually going to wait because I see an ln and I see an absolute value, and there's a few things you might want to do before you actually find the constant of integration c. Okay? So one thing I'm going to do is I'm going to multiply both sides by 5. And so I'll get the ln of 5s minus 3 equals 5 times t, 5t, plus c. But 5 times c, isn't that just another constant c? 5 times a constant is just a constant, so I'm just going to leave it as c. And then, what do I do with ln's? How do I cancel an ln? You're probably asking yourself, why do you want to cancel the ln? Remember, to find the particular solution means you are looking for s of t. You're looking for a function s, so that when you take the derivative of s, you get 5s minus 3. That's all we're doing. Finding a function whose derivative is 5s minus 3. Okay? So then I do need to find this S value, and to find the S value I need to cancel the ln, and to cancel the ln we exponentiate. So we take e and we raise it to that thing. But because it's an equation, now you have to go to the other side and say, well then, I also have to raise e to the 5t plus c. So this is called exponentiating, taking e and raising it to those two sides. On the left-hand side, there's no problem because e raised to an ln cancels out, and you just get the absolute value of 5s minus 3. However, the right-hand side, a few more things are happening. One thing I want to do is to make it easier on me because I know how this is going to play out. And for now, you just have to memorize the steps, and then as you practice your own problems, you'll see that it always plays out the same way. You want to rewrite e to the 5t plus c as the following: e to the 5t times e to the c. And spend a few seconds here making sure you understand why this expression is the same as that expression. And if I could just maybe offer you a different example. If you have x to the third times x to the y, isn't that exactly the same as x to the 3 plus y? So all I'm doing here, I'm saying if you have a sum of powers, like here, 3 plus y, then that sum of powers is the same as a product of the same base with the individual powers. And that's what I'm doing here. A sum of two powers is the same as the product of the same base raised to the individual powers. Okay? And if you remember your Algebra 2 skills, you'll see that this is the same as that. But what it allows me to do is to say that this is now e to the power 5t. And when I think about e to a constant power, isn't that also just another c value? Because e itself is a constant, 2.718. And when you raise a constant to a constant, you get another constant. Now, I'm not saying that this c is the same as that c, or that the c value here is exactly the same as the c value there, or that this c value is the same as the one I had before I multiplied by 5. All I'm saying is, yeah, they're all different constants, but the bottom line is they are constants. So I'm just going to keep on writing the c for a constant. And then my left-hand side remains the absolute value of 5s minus 3. It's actually not a bad idea to bring this c to the front and make it look like a coefficient. So c e to the power 5t. Now, how do you cancel the absolute value? Don't forget, we're trying to solve for s. To cancel an absolute value, all you have to do is rewrite it as plus or minus 5s minus 3. And this is getting us closer to s. And the plus or minus, I'm going to divide it out. And so then 5s minus 3 equals, you can think of this as being a 1, and then I'm dividing both sides by plus or minus. But when I divide 1 by plus or minus, I just get plus or minus on the other side. So I have 5s minus 3 equals plus or minus c e to the 5t. And my advice to you is, when you have an ln and an absolute value, ln with absolute value, it's always best to go about it this way. It probably looks a little convoluted at first, but trust me, if you practice some more of these, you'll see that this is one of the best ways to go about it. So now I have 5s minus 3 equals plus or minus c e to the 5t, and I can now, as soon as I see the plus or minus next to the c, this is the best time to use the initial condition and figure out my c value. However, one other thing I want you to think of is this. Let's think of plus or minus c as its own little thing. Plus or minus c, it's an object. And we are just trying to solve for plus or minus c. So I'm not trying to solve for c, I'm trying to solve for the entire plus or minus c. So now we try the initial condition, and that was s of 0 is equal to 4. And be careful how you read this. It means the s is equal to 4 when the time is 0. That's because s is a function of t, so in essence this is like saying s of t. Okay? And so that's why the s is 4 and the time is 0. And so we plug those in just like you see there. And so we have 20 minus 3, 17 equals plus or minus c. Notice how the plus or minus c, I'm treating it as its own little thing. And be careful, 5 times 0 is 0, but e to the 0 is not 0, e to the 0 is 1. So then you have that 17 is equal to plus or minus c times 1, or just plus or minus c. Now again, I'm looking at plus or minus c as one whole thing, because many students want to come here and then they want to divide both sides by plus or minus, and then they get that c is equal to plus or minus 17, and that's just confusing. You just want to say, hey look, this plus or minus c is equal to 17, so then let's rewrite the original equation, which is down here, or the solution. And then let's write out 5s minus 3 is equal to plus or minus c, which was 17 e to the 5t. Okay? That's how it works. It's just a substitution, direct substitution for plus or minus c. And now we can find s. So 5s is equal to 17 e to the 5t plus 3. And then last but not least, divide by 5. And so there's our expression for s. S equals 17 fifths e to the 5t plus 3 fifths. Now you could also call it s of t if you want. And this is our final particular solution to the differential equation. So I have my particular solution, and I want to prove to you again that this is the particular solution to the differential equation. So remember, you don't have to do this on the AP exam. This is just so that you understand what we are doing when we say find the particular solution or solve the differential equation. So this is the differential equation, ds dt equals 5s minus 3. And we said that this is the function s that makes it true. Let's prove it then. On one side, I'm going to find ds dt. So let's just go right ahead and take the derivative of this function with respect to time. It's quite simple because it's an exponential. So it's going to be 17 fifths. It's just a coefficient, e to the same power, 5t, and then times, by the chain rule, the derivative of the power of 5. And when you take the derivative of 3 fifths, you get 0. Now on the other side, I have to prove that this is equal to 5 times s minus 3. So I'll say 5, then let's make a substitution for s. We said that s equals 17 fifths e to the 5t plus 3 fifths. So that's us just saying, here's s, plug it into here, and then take away 3. And now we have to show that these two sides are equal. And so when you distribute the 5, you can see that the denominators cancel out, and you just get 17 e to the 5t plus 3. And then there's a minus 3 waiting for you out there. So now looking at the left-hand side, the 5's cancel out, and we have 17 e to the 5t. And looking at the right hand side, the 3's cancel out and you have 17 e to the 5t. So it's true. The derivative of s with respect to t is equal to 5 times the function s minus 3. Okay, goodbye.